So trig homework 15 now is continuing on, where we're going to have some application problems where we have to set up our exponential functions and then calculate the value. So we're finding the final amount in a word problem on exponential growth or decay. It says a car is purchased for $28,500. That's our starting amount. After each year, the resale value decreases by 35%. Well, the percent that you want here is the percent it's going to maintain each year. If it decreases by 35%, if you take 100% minus 35%, it's going to retain 65% of its value. So we're going to have 65%, and then to the t power, so to the fourth power. I usually write it in the inside or outside, but if you put it on the inside like they did, either way it should give you the same value. So that's what we're going to punch in. 28,500, whoops, I got an extra 5 in there. 28,500, parentheses, 0.65 to the fourth power. We're rounding to the nearest dollar. I got 5087.4. So $5,087 would be the value. It started out at 28,500, decreased by 35% each year, so after 4 years, it's now only worth $5,087. Second one then, it says amount of $27,000 is borrowed for 10 years at 3.5% interest compounded annually. The loan is paid in full at the end of that period. How much must be paid back? So we're starting out with $27,000. The amount we're going to retain is 100% plus the 3.5%. So on that first one where they gave us the formula, you noticed it was 1.035. The full amount you're still going to have, it's not going to disappear, plus the interest, the 3.5%. We are going to put that in there for 10 years. So 27,000, 1.035 to the 10th power. I get 38,086.1. We're rounding to the nearest dollar. So $38,086 is what we're going to have after 10 years. We only had 3.5% interest, so we didn't make a whole lot of interest, but a little bit. So the third one here is one of those half-life ones. We did those half-life. It says the half-life of a radioactive isotope is the time it takes for the quantity of the isotope to be reduced to half its initial mass. We started with 160 grams. We're going to do the half-life, so 1/2. And we want to know how much will be left after 3 half-lives, so to the 3rd power. On those other ones we did, they said, oh, a half-life takes 10 hours and we had to do a fraction. This is just telling you how many half-lives it would be. Well, I could start with my 160, cut it in half, that would be 1 half-life. Cut it in half, that would be 2 half-lives. Cut it in half, that would be 3 half-lives. But obviously if I had a really big number, I wouldn't want to have to go in half and half and half and half, although I could. Here's my formula. 160, the half-life, and again you could do 1 divided by 2 or 1 fraction 2 to the 3rd power, and we get 20 is what's left after 3 half-lives. After 1, after 2, after 3. Same answer. On 4, 5, and 6, we're now going to do compound interest, and there is a formula for compound interest. It will look sort of like what we've been doing. But what they're going to tell you to do to find compound interest is take the principal, or the amount you started with, 1 plus, and here's where it's a little bit different. Since it's not compounded annually, quarterly, monthly, something like that, you're going to take the rate divided by the number of compounding periods. 4% compounded quarterly means 1% per quarter. Then you have to do to the power, I'm going to put the caret key because that's what we're going to have to use, the number of compounding periods times the time. So if it's compounded quarterly for 10 years, it's compounded 40 times the total number of times it's compounded. So I'm going to invest $4,000. 1 plus 4% compounded quarterly to the 4 times 10. And again, I have to put parentheses so that it doesn't to the 4th and then multiply by 10. So it's going to look something sort of like that. Let's go ahead and punch it in, see what we get. So 4,000 parenthesis 1 plus 0.04 divided by 4. You can use a fraction or the division. I like the division. It's easier for me to punch in. Caret key, and then in parentheses, 4 times 10. Hit equals. I'm coming up with 5955.454. Tells me to round to the nearest cent, so I need to carry it 3 places. Since there's a 4 behind there, I'm going to say $5,955.45. So I started out with $4,000. After 10 years, I didn't make a whole lot of interest, 4% compounded quarterly. So I ended up with $5,955.45. So number 5, same kind of thing. Borrowed 8%, borrowed $8,000 at a rate of 15%. So here we only had 4% compounded quarterly. Here we're going to do 15% compounded semi-annually. So 1 plus 0.15 semi-annually is twice a year. 2 times 3, so it's going to do 6 total times twice a year for 3 years. So 8,000 parenthesis 1 plus 0.15 divided by 2, the parentheses 2 times 3, and I get 12,346.412. So after 3 years, I pay back $12,346.41. So number 6, suppose that we're investing only $2,000. 1 plus my rate, 0.036, 3.6%, compounded annually, so once a year, and 1 times 3. So since this one's compounded annually, you can see if I simplified this, 2,000, 1.036, since that's divided by 1, to the 3rd power. So it's just like our previous formulas. If it's compounded annually, we really don't need the compound interest formula. We can use our regular one, but they'll throw some ones in there that are annually just to see, and you end up getting the same answer either way. Let's go ahead and punch that in. 2,000, 1.036 to the 3rd power. So 2223.869. So $2,223.87 is what we'd have to round that off to. So now we are going to get into converting between logarithmic and exponential equations. A logarithmic equation is an inverse of an exponential equation. If I just did this, if I had 2 to the x power and I made my table and used -2, -1, 0, 1, and 2, 2 to the negative 2 power is 1/4. 2 to the negative 1 power is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second is 4. If I had a logarithmic function with the base of 2, what I'm doing is switching my table. So that if I had log base 2 of 1/4, my answer is going to be negative 2. If I have log base 2 of 1/2, my answer is going to be negative 1. If I had log base 2 of 1, my answer would be 0. If I had log base 2 of 2, my answer would be 1. If I have log base 2 of 4, my answer would be 2. So you can see in my table, everything is just switched around because a logarithmic function is the inverse of an exponential function. So I just switched my x's and my y's. Way back when, there used to be hundreds of tables where you had to look up values. Now you have a calculator where you can calculate the logarithm, and we'll get into that later. But to kind of in your mind get an idea, what is a logarithmic function? It's the inverse of an exponential function with whatever base is listed here. Well, obviously I wouldn't want to have to go through all of that. So what they're going to have you do then is basically have a little formula. And they're going to say if you have the log base b of a equals c. I don't know why they use a and c instead of x's and y's, but they seem to do that on at least Alex. When we rearrange it, it's going to be b to the c power equals a. I'm just thinking about, I'm switching these two things around. My base stays the same. So if I look at this, my base is 3, so log base 3, and then I'm going to switch the exponent and the answer around. So the 1/9 goes here and the negative 2 goes here. So log base 3 of 1/9 ends up being equal to negative 2. Later on we'll figure out how to calculate that and we'll actually find the answer. But at this point they just want you to get comfortable rearranging. So on 8, same kind of thing. My base is 2, so log base 2, I'm going to switch the exponent in the answer. So the 1/2 will go here, the negative 1 will go here. So log base 2 of 1/2 ends up being equal to negative 1. I erased my table, but otherwise we could have looked. The next one, they're going to have us go the other way around, which is probably more common as what you're going to be doing in order to solve equations. I'm going to be in logarithmic form. I want to write it in exponential form. My base number is 2, so base 2, and then I switch these two things around. The negative 3 is the exponent. There should be an equal in there, 1/8. So 2 to the negative 3rd power is 1/8. Now that should be a true statement. 2 to the negative 3rd power, you do 1/2 cubed, and 1/2 times 1/2 times 1/2 is 1/8. So yes, that's a true statement. So just getting used to switching those around from logarithmic form to exponential form, or exponential form to logarithmic form. (10, 11, and 12 are converting between natural log and exponential functions. Natural log have an understood base of e. So if I have the natural log base e of x equals y, when I switch it around, e to the y power equals x. I'm not sure on Alex if they put the y first or the x first, but it really doesn't matter. It's the same thing. I'm just switching the x and the y around, keeping in mind that a natural log is base e, even though the e is not written there. So if I have the natural log of 5 equals y, I know that it's the natural log base e of 5 equals y. So e to the y power is going to be equal to 5 when I rearrange that. Here I have it written in base e exponential form, and so I want it in logarithmic form. Since it's base e, I know it actually has to be natural log. So the natural log base e of 7 equals y. However, I don't need the e in there, so I'm just going to say the natural log of 7 equals y, and that's going to be the best form for my answer. And so here, the natural log base e of 4 equals x. Again, the e is not written there, but I don't really need it. I know that that's going to be e to the, and the x is going to be my exponent, equals 4. So e to the x equals 4. So natural log converts the same way as a logarithm. It's just that it's understood to be base e, because that's the inverse for a natural log. So 13, 14, and 15, we are now going to evaluate a logarithmic function. These ones we're going to do without using our calculator. We're going to do by rearranging them. So again, if I have log base b of a equals c, then b to the c power equals a. So in this case, I'm going to put equals c, just so it looks like my logarithmic function. But what I'm saying is 2 to this power equals 16. So 2 to the c power equals 16. And it doesn't really matter what variable you put over there. You could put an x there. But now you just have to use your brain and figure out, well, what 2 to what power is 16? Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 4 of them. So since 2 to the 4th power equals 16, my answer here would have to be 4. The log base 2 of 16 is equal to 4. So, the next one, say I put an x there. It wouldn't really matter. I'm just rearranging it in exponential form. My base is 6. 6 to what power equals 136? So now when you think of that one, you have to think about, oh, how did I get the reciprocal? I had to have a negative exponent. 6 to the 2nd power is 36, so 6 to the negative 2 power would give me 1 over 36. So negative 2 would have to be my answer. Log base 6 of 136 is going to be equal to negative 2. So number 15, same kind of thing here. I'll slide it up a little bit. Again, doesn't matter what variable I put over there. I'm just going to put an x for fun. 5 to what power equals 1? Well, again, I have to use my brain. Anything to the 0 power equals 1. So I'd have to have a 0 there. Log base 5 of 1 equals 0. Anytime there's a 1 there, I'm always going to get a 0 because anything to the 0 power equals 1. So a matter of using what you know once it's rearranged in exponential form. If you need to, use your calculator, plug some numbers in till you find the right answer. But that one you got to remember. Anything to the 0 power is 1. So 16, 17, and 18, now we're going to find some values other than the n number, but still using the same thing. If I have log base b of a equals c, then b to the c power equals a. And so here I would say 4 to the 2nd power equals x. Well, that's pretty easy to do. 4 to the 2nd power is 16. So my answer there is going to be 16. On this one, I have to find the base number. What to the negative 3rd power equals 1 over 1,000? So I want to think about the opposite. What to the 3rd power equals 1,000? In order to solve that, I could do the cubed root, right? Because that's the opposite. The cubed root of 1,000 is 10. So, since I had to do the reciprocal, my exponent was negative. Since 10 to the 3rd is 1,000, that means 10 to the negative 3rd is 1 over 1,000. So x is going to be 10. the log base 10 of 1 over 1,000 would equal -3. So these ones here where you're missing the base are a little bit harder. Since it was negative, I did the reciprocal, and then think about doing the opposite. The opposite of cubing is the cubed root. What's the cubed root of 1,000? 10. 10 times 10 times 10 is 1,000. Number 18, that one's back to an easier one because I can just put it in exponential form. 3 to the third power equals x. Well, 3 to the third is 27. So that's a lot easier than when the base is missing. Then I've got to do a little bit more work to solve it.